Hey folks, I hope you had a wonderful weekend. Thanks for watching my video and setting up your notes just like you see here on the screen. You just watched a video about how does a circle get transformed more or less into a rectangle. We're cutting it up into a lot of different sectors. These are called sectors when you draw like a little piece of the circle like that, right? That guy in his video, he drew a lot of these, didn't he? And then he rearranged them and they formed a rectangle. So we had a sector right here and a sector right here. And the more of those sectors he had, the more perfectly it fit into a rectangle, of course, right? And so he said this side over here was the radius, and this part right down here is half the circumference. So this is the kind of stuff that I want you to put in your notes. I want you to put down, okay, so that rectangle is going to be the radius times half of the circumference. And circumference, he used the formula 2 pi r. I like the formula pi times diameter, but either one's going to work for us. Half of 2 pi r, and the half times the 2 gave us the 1. And then with multiplication, you can reorder the way that you're multiplying numbers. You don't have to multiply like r times 2 or r times pi. You can go r times r over here. And so the 1/2 times the 2, he said those cancel out. They go to 1. And so we're down to pi r squared. So this is our formula that we're going to use today, which you guys might be going, well, duh, Nelson, I didn't need to see a proof of that. I didn't need you to go over it. I know that formula right there. But that's kind of the cool part about mathematics is that, people prove that all of the things that we use are true and that we can use our own intellect to follow their proof. We might not be able to generate a proof like that. We might not have thought of doing the proof that way, but it's pretty cool when we look at it and go, man, human beings thought this stuff up and proved that it's true and figured things out that are in our natural world. But anyways, we've got two types of problems that we're going to do today. I'm going to go over them I'm going to go over problem number 1 in this video, and then you're going to try problem number 1. Then you're going to watch the next video and you're going to try problem number 2. And then you'll have kind of the basic gist of how the whole assignment's going to work. The last couple of problems are a little different. I'm not going to give you an example for those problems. I want you to use your deductive reasoning to try to figure out the answers to those. So they're a little challenging. So you can see our formula has radius in it. It doesn't have the diameter, right? So this is the diameter. The first problem here that I'm giving you is a bit of a trick here. We got to figure out what the radius is. Well, that's not too hard, right? The radius is half of the diameter. The radius would be this part right here, and that would be 9 long. So I put a 9 down, and then the area would be pi times 9 squared. So let's see, that comes out to be 81 pi. Now, if they say in their problem, I didn't copy the directions, if they say, give me the exact value, do not multiply 81 times pi. If they want an approximation, which they might say round to the nearest tenths, then we're going to go over here to Desmos, right? And I want to show you something kind of cool on Desmos here, that when you type in 81 and then type the letters P and then I, it'll change it to a pi symbol, right? I think we've talked about that a little bit. It's using as accurate as possible for pi. And 254.5, if we round to the nearest tenth, 254.5. So let me put an approximation, 254.5, right? 254.5. And then let's see, it's in inches. So we're going to have square inches. They'll probably have that after the box, after the box that you're typing your answer in. Now, let's say they tell us to use 3.14 for an approximation. Sometimes math books do that. 81 times, then we go 3.14. And you notice that it's significant. Well, not significantly, but it's not the same to the tens place. This would be 254.3. So if pi is approximately 3.14, if that's what they tell us, then we're going to say the area is approximately 254.3 square inches. So you really have to be careful. Why do math books tell us to use 3.14? I don't really know. I mean, we have Desmos. Desmos will do it way more accurately, 3.14. It takes it like look, if I type in pi right here, Pi, I mean, it'll take it out even further if I tell it I want to see 50 decimal places, right? So 3.14 is good, but not perfect. Anyways, there's more to that. I like stories about pi. It's an important number in mathematics. But thanks for watching my first video. You go and try to put problem number 1 in. Be careful how it asks for the answer, and then watch the next video and do problem 2, and then you'll be set for your notes.